Good morning, students. Right now, let's continue with lesson number 3, metals and non-metals. Yesterday, we discussed about certain physical properties of metals and some physical properties of non-metals, and we compared them. We also realized that comparison and classification of elements into metals and non-metals only on the basis of physical properties is not enough. For example, we saw that metals are hard, okay, but at the same time there are some exceptions. Sodium, potassium and lithium are metals, but they are very soft. You can cut them with a knife, okay. On the other hand, you've got metals like gold, platinum, silver, aluminium, iron, copper. They are all very hard, okay. So some elements, although they are metals, their properties are slightly different. They are exceptions to the rule, okay. For example, iodine is a non-metal, but it is lustrous. Metals are supposed to be shiny, okay, but there are certain non-metals also which are shiny. Then on the other hand, you have alkali metals like lithium, sodium, potassium, which are soft and you can cut them with a knife. The densities are low, the melting and boiling points are also low. But most metals like iron and copper, they got high melting and boiling points. But sodium, potassium and lithium have got low boiling points, melting points. So you see there are certain contradictions or rather exceptions to the rule. And that is why physical properties alone is not enough. Just the physical property is not enough to determine whether it's a metal or non-metal. We have to study them further. And the best way to study them is of course through chemical properties. So now we'll come to some chemical properties, okay. Now just see here, activity 3.8 we had come up till yesterday. Take a magnesium ribbon and some sulfur powder. Sulfur powder is greenish yellow in color. Magnesium ribbon, when you burn it in air, okay, there was a time when magnesium ribbon was used for photography. When magnesium ribbon is burnt in air, it will produce a dazzling white flame. Okay, it will burn with a dazzling white flame. So what will happen is it will produce a lot of light. And that it's at that time about 100 years ago or 70, 80, 90 years ago, although the camera was invented, but you see photography was very simple. And at the same time there was no flash. So अगर डार्क रूम में फोटो लेना है तो क्या करेंगे, तो वो मैग्नीशियम रिबन को बर्न करते थे. They would burn a magnesium ribbon. The magnesium ribbon would produce a flash of light. It does not burn instantly. It will take a few seconds to burn, and during that time you can take a photograph. So magnesium ribbon burns with a dazzling flame to produce magnesium oxide. Okay, उसका एक white ash आता है. जैसे ही मैग्नीशियम रिबन को बर्न करेंगे तो उसका पाउडर व्हाइट ऐश जैसा हो जाएगा और उस व्हाइट ऐश को पानी में डिसॉल्व करोगे तो यू गेट मैग्नीशियम हाइड्रोक्साइड. इन अदर वर्ड्स, मैग्नीशियम which is a metal produces magnesium oxide when it burns in air, but that magnesium oxide when it is dissolved in water produces magnesium hydroxide, which is a base. Okay, so all oxides of metals are basic in nature. Now that's the important property to remember. You see, instead of remembering a chemical equation, remember the property. Oxides of metals are basic in nature. So when a metal is burnt in air, when you burn a metal, that is when a metal reacts with oxygen, it produces the corresponding metal oxide. For example, sodium reacts with oxygen to produce sodium oxide. Potassium reacts with oxygen to produce potassium oxide. Lithium produces lithium oxide. Magnesium produces magnesium oxide. Copper produces copper oxide. Okay, so whenever a metal reacts with oxygen, then it produces the corresponding oxide. But these oxides of metals, when they are dissolved in water, they form the corresponding hydroxide, MgOH twice, magnesium hydroxide. And of course, hydroxides are all basic in nature. They are alkalis, solutions of alkalis. So that is why you have to remember the general property. Alright, in the same way sulfur is a non-metal. It is not a metal like magnesium. Sulfur, when it combines in air or when it is burnt in air, it produces sulfur dioxide or SO2. Okay, this SO2 when it is dissolved in water forms H2SO3. H2SO3 is sulfurous acid, not sulfuric acid but sulfurous acid. Sulfurous acid is an acid. So that means metal oxides produce bases, non-metal oxides produce acids. So non-metal oxides are acidic in nature, metal oxides are basic in nature. Okay, so that is what is written out here. Okay, that is, let's see, most known metals produce acidic oxides like magnesium oxide. When dissolved in water, they produce magnesium hydroxide, potassium hydroxide, sodium hydroxide. On the other hand, most metals give rise to basic oxides. You'll be learning more about these metal oxides in the next section. Okay, so let us see here now. All these questions are there in the PDF. We'll discuss that. You can read that in the PDF. Now, chemical properties of metals. So now this is important. This is where real chemistry begins. Physical properties are different. They are physical properties. They have nothing to do with chemical combination. Okay. So now let us see chemical properties of some of the samples here. Take samples of metals like aluminum, copper, iron, lead, magnesium, zinc, and sodium. These are all metals. You can take small pieces of these metals and then burn them in the air and see how they react with oxygen. What happens when metals are burnt in air? You have seen in activity 3.8 that magnesium burns in air with a dazzling white flame, and that's why it was used in photography. Do all metals react in the same way? Let us check by performing following activity. Now, obviously, just as all students don't do very well in science or maths, in the same way, all metals do not react equally with oxygen. For example, gold and silver. They are very unreactive metals. They are metals, but they are very unreactive, and that's why they don't react with oxygen. On the other hand, iron and copper are also reactive, but they are very slow reactive. In other words, they will react with oxygen. Copper will react with oxygen to form copper oxide. Zinc will react with oxygen to form zinc oxide. And similarly, any other metal, even silver does not react to produce silver oxide or gold oxide, because they are very unreactive metals. And that is why gold does not become dark. Okay, वो डार्क क्यों नहीं होता है? क्योंकि उसका रस्टिंग नहीं होता है. रस्टिंग क्यों नहीं होता है? क्योंकि वो ऑक्सीजन के साथ रिएक्ट नहीं करता है. आयन लोहा, ओके, आयन रिएक्ट्स विद ऑक्सीजन बट वेरी स्लोली. इसलिए रस्ट, फेरस ऑक्साइड, FeO, ferrous oxide is nothing but the slow reaction of iron with oxygen. Now that is called rusting of iron, and that process is very slow. Okay, it takes place after a week or 2 weeks, 3 weeks, and so on. All right. Now let us just see this activity here. The following activity needs the assistance of teachers. It would be better if students wear eye protection. In fact, in the chemistry lab, whenever an experiment is conducted in the chemistry lab, one has to be careful. Use all precautions possible. Okay, hold things with a pair of tongs if necessary. Wear sunglasses, those eye glasses. Special glasses are there. They are not sunglasses, but they are special glasses which can be used in the lab. They are generally made of plastic. Okay, they just provide protection. They are very clear and plastic. Sides में से अच्छी तरह से होते हैं, and you can wear it to protect your eyes. Okay. At the same time, you can even wear a plastic cap also to protect your head rather to protect your hair from the bleaching agents which are in the laboratory. And you can wear gloves also. You can wear an apron. Apron जो आगे कपड़ा होता है, जो cooks पहनते हैं किचन में. Apron भी पहन सकते हो ताकि आपके कपड़े खराब ना हो. So, following activity requires the assistance of teachers. It would be better if you wear eye protection. Hold any of the samples above, which was given above, with a pair of tongs and try burning over a flame. Repeat with other metal samples. Collect the products if found. Let the products and the metal surfaces cool down, and when metals burn easily or non-metals burn easily, what is the color of the flame? What are the products? Okay, how reactive are they? Then can they be soluble in water? Check all those things, and you will find that they are different for different metals. And this is the beauty of chemistry. Although there are general rules, but there are exceptions also. Okay. Now, almost all metals, you see what is highlighted over there. Almost all metals, just a second. Yes, you can see this activity. Okay. Almost all metals combine with oxygen to form metal oxides. In other words, magnesium combines with oxygen to form magnesium oxide. Now you see there is a general reaction out there. देखो ये general reaction क्या लिखा है? Metal plus oxygen gives metal oxide. अब ये मैंने बाद में देखो इधर बाजू में भी मैंने लिख दिया है. Okay, learn this general reaction. General reaction को learn करके specific reaction लिखना आना चाहिए. You should be able to write specific reactions. जैसे देखो इसके नीचे copper plus oxygen gives copper oxide. Copper is a metal. It reacts with oxygen to give copper oxide. Magnesium is a metal. Magnesium reacts with oxygen to give magnesium oxide. Okay, so you should be able to write specific reactions, but only if you have learned the general reaction. Metal plus oxygen gives metal oxide, and then this metal oxide, when dissolved in water, gives the corresponding metal hydroxide. Okay, Then you can see उसके नीचे लिखा है aluminium reacts with oxygen to give aluminium oxide. Okay, and this aluminium oxide again will react further. Okay, just see that. Recall how copper oxide react with hydrochloric acid. We have learned that metal oxides are basic in nature. Okay, but some metal oxides such as, now this is the important question. See, I have written the question out here. Okay, this is an extremely important question. What are amphoteric oxides? Give an example of such an amphoteric oxide. Amphoteric oxides are basically oxides of metals which have both properties, acidic properties as well as basic properties. देखो metal oxides को generally basic properties होता है. Basic properties क्यों? क्योंकि वो पानी में dissolve करो तो hydroxide हो जाता है. But there are certain exceptions. For example, zinc oxide and aluminum oxide. Zinc oxide और aluminum oxide दोनों amphoteric oxides है. Amphoteric oxide मतलब oxides of metals which show both properties, acidic properties as well as basic properties. Again, look there. Okay, but some metal oxides such as aluminum oxide, zinc oxide show both acidic as well as basic properties or behavior. Such metal oxides which react with both acids as well as bases to produce the corresponding salts and water are known as amphoteric oxides. Now this is an obvious question, quite an important question. Aluminum oxide reacts in the following manner with acids and bases. Now see, aluminum oxide is amphoteric. Okay, अब देखो उसका reaction देखो. Aluminum oxide Al2O3, it reacts with hydrochloric acid to give aluminium chloride AlCl3 plus water. आगे का जो number है, that is balancing chemical reactions. A chemical reaction should always be balanced. But remember one thing, balanced chemical reaction को learn नहीं करना है. तुम्हें सिर्फ जनरल रिएक्शन और उस जनरल रिएक्शन से ऊपर से स्पेसिफिक रिएक्शन. बैलेंस जो आगे 6, 2, 3 जो बैलेंसिंग करने के लिए, मॉलिक्यूल्स को बैलेंस करने के लिए, एटम्स को बैलेंस करने के लिए नंबर लिखे हैं, वो नंबर को याद करने की कोशिश मत करो. That is stupidity. Okay, learn the reaction only, general reaction. So aluminum reacts, aluminum oxide reacts with hydrochloric acid and it also reacts with sodium hydroxide which is a base. दोनों में एल्यूमिनियम का सॉल्ट आता है. Aluminum chloride AlCl3 is a salt of aluminium. Similarly, sodium aluminate NaAlO2, sodium aluminate is also a salt of sodium and aluminium. Okay, it's a compound salt. Why compound salt? Because इसमें सोडियम और एल्यूमिनियम दोनों का सॉल्ट है. सोडियम ऑक्साइड नहीं है, सोडियम एल्यूमिनियम ऑक्साइड it is. So sodium aluminate, and that's why it's called a compound salt. So this is the reaction of aluminum oxide with both acids and bases, and that's why it is called amphoteric oxide. All right. Now, most metal oxides are insoluble in water, but some of these dissolve in water to form the corresponding alkali. Now, what is an alkali? An alkali is an aqueous solution of a base. Okay. What is an alkali? An alkali, you can see here. Okay, if I want to write a question, I can write. आगे वैसे किया तो है. What are alkalis? Okay, an alkali is an aqueous solution of जैसे sodium. Okay, aqueous solution of sodium hydroxides of metal oxides, metal hydroxides. Okay, जैसे metal hydroxide मतलब sodium hydroxide. अब सोडियम एग्जाम्पल, सोडियम हाइड्रोक्साइड solution in water. Okay, sodium hydroxide is a base. When it is dissolved in water, you get an alkali. What is this alkali? Aqueous solution of sodium hydroxide. Now you can see वहाँ पे sodium oxide Na2O. Sodium oxide when it is dissolved, or potassium oxide K2O, when they are dissolved in water, you get an alkali. That means the solution, hydroxide solution in water. NaOH, उसके बाजू में देखो AQ लिखा है. AQ मतलब क्या है? Aqueous. Aqueous मतलब क्या? When a substance is dissolved in water, it is called an aqueous solution. Okay, the word aqueous comes from the word water. So potassium hydroxide also means aqueous solution of potassium hydroxide. Potassium hydroxide can be in solid powdery form also. But जैसे ही उस पाउडर को पानी में डिसॉल्व करते हैं ना, तो पोटेशियम हाइड्रोक्साइड का एक्वियस सॉल्यूशन बन जाता है. सोडियम हाइड्रोक्साइड पाउडर फॉर्म में भी होता है, ड्राई पाउडर. उसको जैसे ही पानी में डिसॉल्व करते हैं, वो सोडियम हाइड्रोक्साइड का एक्वियस सॉल्यूशन बन जाता है. ओके, दैट इज एन अल्कली. ऑलराइट, सो Sodium hydroxide and potassium hydroxide, you can see they react with water to form the corresponding hydroxides or aqueous solutions or alkalis. Alright. Now, see that I have written one more question here. Why are metals such as sodium and potassium stored in kerosene? Now, we have discussed this before. Some metals are more reactive than others. Sodium and potassium are the most reactive metals. सबसे ज़्यादा reactive metal है potassium और sodium. ये दोनों इतने reactive है कि उसको खुली हवा में नहीं रख सकते हो, क्योंकि वो भेज, हवा का जो भेज है ना, पानी है, मॉइस्चर है, उसके साथ भी रिएक्ट करेगा, ऑक्सीजन के साथ भी रिएक्ट करेगा, एंड एकदम विगरसली रिएक्ट करता है, एकदम फास्ट रिएक्ट करता है, एंड इट प्रोड्यूसेस व्हाट? इट प्रोड्यूसेस हीट. Okay, that is why it is an exothermic reaction. In fact, the reaction of sodium and potassium with oxygen is a highly exothermic reaction. Okay, when it reacts with water, highly exothermic reaction, and as a result of which lot of heat is produced, and hydrogen gas is also produced. When metals react, they produce hydrogen also. This hydrogen gas bubbles out very quickly, and not only that, but since a lot of heat is produced, that it can catch fire. So that is why reaction of sodium and potassium with water is an extremely dangerous reaction. One has to be careful. But they are also metals. They are soft metals. Okay. कॉपर और आयरन एकदम हार्ड मेटल है, उसको तो रिएक्ट करना अलग ही चीज है, लेकिन सोडियम और पोटेशियम को केरोसिन में रखना पड़ता है, वरना वो ऑक्सीजन और पानी के साथ रिएक्ट करेंगे. We have observed in activity 3.9 that all metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. Metals such as potassium and sodium react vigorously, एकदम fast, तेजी से react करते हैं. Then they catch fire if kept in the open. Okay, hence to protect them and to prevent accidental fires, they are kept immersed in kerosene oil. केरोसिन के अंदर बोतल होती है, बड़ी बोतल, बोतल के अंदर केरोसिन होता है, केरोसिन में सोडियम और पोटेशियम को रखते हैं. At ordinary temperature, मतलब room temperature 25 डिग्री, 30 डिग्री, 32 डिग्री. At ordinary temperature, the surface of the metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of the corresponding oxide, magnesium oxide, calcium oxide, sodium oxide. The protective oxide layer prevents the metal from further oxidation. ये जो ऑक्साइड का लेयर ऊपर होता है ना, उसकी वजह से डल हो जाता है मेटल, शाइनी नहीं होता है, लेकिन ये प्रोटेक्शन भी है. The oxide of the metal protects it. इसलिए अगर उसको स्मूथ करना है तो सैंड पेपर से रब करो, सैंड पेपर से, तो ऊपर ऑक्साइड का जो लेयर है निकल जाएगा, it will become bright and shiny. लेकिन कुछ दिन के बाद फिर से ऑक्साइड का लेयर ऊपर आ जाएगा. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but iron filings मतलब छोटे-छोटे आयन के टुकड़े, बाल जैसे. Iron filings burn vigorously when sprinkled in the flame of the burner. Copper does not burn, but the hot metal, that is hot copper, is coated with black colored copper oxide. Silver and gold do not react with oxygen at all at high temperatures. इसलिए तो सिल्वर और गोल्ड इतने काले नहीं पड़ते हैं. देखो ये सब मेटल्स है, लेकिन उसका रिएक्शन सेम नहीं है, उसका रिएक्टिविटी अलग अलग है. हाउ दे रिएक्ट विद वाटर, हाउ दे रिएक्ट विद ऑक्सीजन, इट्स ऑल डिफरेंट. सम मेटल्स डोंट रिएक्ट, सम मेटल्स रिएक्ट विगरसली, some metals react with hot water, some metals react with cold water, some metals react with steam. Okay, steam के साथ react करते हैं, और कुछ बिल्कुल react नहीं करते हैं. So one has to be careful. Chemistry में there is always a lot of work that is new to digest and learn. Alright, now there is a question here again. What is anodizing? Now anodizing is an electrochemical process. Okay, it is done with the help of electricity. It's an electrochemical process. Now let's understand what it is. Anodizing is a process of forming a thick layer of oxide over a layer of aluminium. मतलब aluminium oxide का layer aluminium के ऊपर ही हो जाता है, लेकिन ये layer एकदम पतला होता है. It's a very thin layer and it provides protection but not too much protection. तो उसको थोड़ा सा thick करने के लिए anodizing process होता है. Aluminium develops a thin oxide layer when exposed to air. This aluminum oxide coat makes it resistant to further corrosion. It is protective in nature, but this is not enough because the layer is very thin. The resistance can be further improved by making the oxide layer thick. During anodizing process, a clean aluminum article is made an anode, that is a positive electrode, and is electrolyzed with dilute sulfuric acid. Electrolysis is carried out in an electrolytic vessel, और उस vessel is always filled with a salt of the metal, and electricity is passed through that. The oxygen gas evolved at the anode reacts with aluminum to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminum articles an attractive finish. उसको एकदम aluminum को एक smooth layer बन जाता है and aluminum looks attractive. Right? That is anodizing process. What is anodizing? After performing activity 3.9, you must have observed that sodium is the most reactive of the samples of metals that are taken here. The reaction of magnesium is less vigorous. इतना नहीं होता है, implying meaning that it is not as reactive as sodium. But burning in oxygen does not help us to decide about the reactivity of iron, zinc, copper or lead. Let us see some more reactions to arrive at conclusions about the order of reactivity of metals. देखो, जैसे फॉर एग्जाम्पल 40 स्टूडेंट होते हैं क्लास में, सबको मैथ्स का टेस्ट दे देते हैं. जैसे ही सबको मैथ्स का टेस्ट देते हैं तो पता चलता है कौन मैथ्स में हो जाए, लेकिन वो तो एक ही सब्जेक्ट में पता चल जाता है. फिर हम जब उसको 5-6 सब्जेक्ट का देते हैं, फिजिक्स का भी सॉर्ट ऑफ साइंस का देते हैं, मैथ्स का देते हैं, लैंग्वेजेस का देते हैं टेस्ट, फिर उसमें से पता चल जाता है कि कौन ऑलराउंडर है, सब सब्जेक्ट में अच्छा कर सकता है. ओके, सो दैट इज द वे यू डिसाइड. सिर्फ रिएक्टिविटी और विद ऑक्सीजन, किस ऑक्सीजन के साथ कैसे रिएक्ट करता है, पानी के साथ कैसे रिएक्ट करता है, इससे पता नहीं चलता है. यू वांट मोर एग्जांपल्स, यू वांट टू सी हाउ दे रिएक्ट विद डिफरेंट सब्सटेंसेस. उसके बाद पता चलता है कौन सा मेटल ज्यादा रिएक्टिव है, कौन सा कम है. ऑलराइट, व्हाट हैपेंस व्हेन मेटल्स रिएक्ट विद वाटर. ना ऑक्सीजन के साथ हो गया, अब मेटल्स रिएक्टिंग विद वाटर. This activity again needs teacher's assistance. Collect the samples of metals like calcium, sodium, potassium, magnesium, so on. Put small pieces of these metals, okay? Put small pieces of these metals, okay, in a half-filled beaker with cold water. Which metals react with cold water? Then after that, okay, अगर कोई metal react करता है, जिसके सोडियम और पोटेशियम react करेंगे, they are highly reactive, इसलिए कोल्ड वाटर के साथ भी रिएक्ट करेंगे. लेकिन उसके अंदर आयरन और जिंक रख दो तो कोई फर्क नहीं पड़ेगा, कुछ नहीं होगा, because they do not react with cold water. Now, did any metal produce fire or water? Yes, probably sodium and potassium. Does any metal start floating after some time? You see, some metals will start floating. For example, अगर कैल्शियम है, कैल्शियम starts floating because जब वो रिएक्ट करते हैं ना वाटर के साथ तो हाइड्रोजन गैस निकलता है. ये हाइड्रोजन के बबल्स हो जाते हैं पानी में, और उसके साथ कैल्शियम मेटल के टुकड़े, उसके साथ पाउडर, उसके साथ स्टिक हो जाता है. सो कैल्शियम विल स्टार्ट फ्लोटिंग ऑन द सरफेस ऑफ वाटर. डिड एनी मेटल प्रोड्यूस फायर ऑन वाटर? डज एनी मेटल स्टार्ट फ्लोटिंग आफ्टर सम टाइम? पुट द मेटल्स दैट डिड नॉट रिएक्ट विद कोल्ड वाटर इन बीकर्स हाफ फिल्ड विद हॉट वाटर. ना फिर हॉट वाटर के साथ टेस्ट करो. जो सोडियम और पोटेशियम को बाजू में रख दो, क्योंकि वो तो कोल्ड वाटर के साथ भी रिएक्ट करते हैं. अब दूसरे को हॉट वाटर में डालो. हॉट वाटर के साथ जो रिएक्ट करते हैं उसको बाजू में रख दो, जो नहीं रिएक्ट करते हैं उसको स्टीम के साथ रिएक्ट करो. स्टीम के साथ जो भी रिएक्ट नहीं करते हैं उसको अलग कर दो. सो दैट इज हाउ यू कम टू नो which substances, which metals react with hot water, cold water and with steam. Right? Then put the metals down, did not react with hot water, arrange the apparatus and find out whether they react with steam or not. Which metals did not react even with steam? Arrange the metals in different orders of reactivity with water. Alright, let's check that out now. You can see there is an experiment which is set up here. Okay, action of steam on metal. देखो steam एकदम गर्म होता है, हमारा उंगली और स्किन जल जाएगा. You have to be very careful. When in chemistry lab, it is always important to be more careful because you are dealing with chemicals. And कौन सा केमिकल किसके साथ कैसा रिएक्ट करता है वो मालूम नहीं है. अपने फिजिक्स और केमिस्ट्री लैब में, खास करके केमिस्ट्री लैब में बहुत बार ऐसा हुआ है. आप जब, क्योंकि बच्चे कभी कभी खेलते हैं तो कुछ गलत हो जाता है, एंड समटाइम्स there is a small amount of fire, not big accidents but small accidents. Okay, glass wool soaked in water. Glass wool actually क्या है? Glass wool is nothing like but fiber like. Okay, वो फाइबर जैसे टुकड़े होते हैं छोटे छोटे, and it is not really wool. वो wool नहीं, उसको glass wool बोलते हैं. It is soaked in water ताकि वो थोड़ा सा मॉइस्चर उसमें हो जाए. फिर एक हार्ड ग्लास टेस्ट ट्यूब होता है, उसमें एक कॉर्क लगा देते हैं, and there is a delivery tube. Now that metal is burned, but in front any metal sample like copper. Okay, कॉपर को ले सकते हो, आयरन को ले सकते हो, कोई भी सैंपल ऑफ अ मेटल. ग्लास वुड सोक्ड इन वाटर ताकि उसमें से स्टीम निकले. ओके, वाटर में सोक करना जरूरी है क्योंकि जो नीचे बर्नर है, द बर्नर विल हीट इट, उसको गर्म करेगा तो पानी गर्म हो जाएगा, स्टीम हो जाएगा, देन द स्टीम विल पास थ्रू द मेटल। अब वो मेटल स्टीम के साथ रिएक्ट करता है कि नहीं करता, वो चेक करना है। ओके, देन देयर इज अ डिलीवरी ट्यूब। अब ये डिलीवरी ट्यूब क्यों रखा है, क्योंकि इसमें से रबर कॉर्क के अंदर एक होल है, वो गैस को सिर्फ डिलीवरी ट्यूब में जाने देगा। इसमें जो मेटल के साथ स्टीम रिएक्ट करता है तो हाइड्रोजन गैस होगा। ये हाइड्रोजन गैस इज insoluble in water, it will bubble out and you can collect it in a bell jar, okay, in a gas jar। गैस जार में उसको कलेक्ट कर सकते हो या तो बड़ी टेस्ट ट्यूब में कलेक्ट कर सकते हो और फिर उसको टेस्ट करो हाइड्रोजन के लिए बाय पुटिंग अ फ्लेम और अ मैच स्टिक वेरी क्लोज टू, अगरबत्ती भी लेके उसको टेस्ट कर सकते हो। So this is how you find out whether metal reacts with steam or not, but you have to be careful while doing this experiment. Okay, metals react with water and produce metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolve in it for further to form metal hydroxides, but all metals do not react with water. Now look at the general reaction which I have told you before. Okay, metal when it reacts with water forms metal oxide plus hydrogen gas. For example, zinc when it reacts with water will form zinc oxide plus hydrogen gas. But does zinc really react with cold water or hot water? Probably not. इसलिए हम जिंक को क्या करते हैं, जिंक को एसिड के साथ रिएक्ट करते हैं when we want to produce hydrogen gas. Magnesium again does not react with cold water, but it reacts with hot water. Metal oxide plus water gives metal hydroxide, and that is why metal oxides are considered basic in nature. ये जो जनरल रिएक्शन है उसको लर्न करना है, जैसे मैंने बाजू में इधर लिखा है, learn these general reactions. It is the general reactions that you should be learning and not specific reactions. Metals like potassium and sodium are highly reactive with water. They will react with cold water also very vigorously, and in fact you have to be very careful because they will produce hydrogen gas and that hydrogen can catch fire because the reaction is highly exothermic. उसमें गर्मी बहुत पैदा होती है। Metals like sodium and potassium react violently with cold water. In case of sodium and potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. Okay, I have written a question here. Such reactions are called exothermic reactions. Which reactions are called exothermic reactions? Reactions in which heat energy is liberated. Okay, reactions in which heat energy is liberated, okay, are called exothermic reactions. Reactions in which heat energy is liberated are called exothermic reactions. Okay, so reactions in which heat energy is liberated are called exothermic reactions. And you can see here potassium and sodium both react with water to form hydrogen gas, but they also liberate a large quantity of heat, इसलिए उसको exothermic reactions बोलते हैं। लेकिन जो हाइड्रोजन के साथ अगर हीट मिक्स करो ना, it is explosion. Hydrogen will catch fire. So that's why even एक सोडियम का छोटा टुकड़ा है, you have to be very careful, इसलिए उसको केरोसिन में रखते हैं। Alright, then the reaction of calcium and water is less violent. Okay, the heat evolved is not so much. It is exothermic, but not so much. इसलिए calcium will not catch fire, hydrogen will not catch fire. Sorry. Okay, and there will be bubbles of hydrogen gas. They will lift the calcium out, and calcium will stick to it. Okay, the reaction of calcium and water is less violent. The heat evolved is not sufficient for the hydrogen gas to catch fire, but the calcium starts floating because the bubbles of hydrogen gas form stick to the surface of the metal. Again, I have written a question out here. Why does calcium start floating when calcium reacts with water? The answer is there. You see, those who read the chapter carefully, only they can answer such questions. And some of you are so habituated कि तैयार क्वेश्चन आंसर्स चाहिए, फिर टेक्स्ट बुक नहीं पढ़ते हैं, फिर ये इस तरह के क्वेश्चन आंसर करना मुश्किल हो जाता है। Okay, so the question is, why does calcium start floating when calcium reacts with water? Because it is exothermic, it produces hydrogen gas, but the heat produced is not sufficient to light up hydrogen. Okay, burn hydrogen, and the hydrogen bubbles pull calcium particles along with it, and therefore calcium begins to float. Magnesium does not react with cold water, it reacts with hot water to form magnesium hydroxide and hydrogen gas. It also starts floating due to the bubbles of hydrogen gas sticking to the surface of hydrogen gas. Alright, metals like aluminium and iron Metals like aluminium, iron, zinc do not react either with cold water or with hot water, and therefore you cannot use zinc or iron to produce hydrogen gas, but they react with steam to form metal oxides and hydrogen. इसलिए देखो aluminium और iron Fe उसका reaction with steam, okay, that is important. This reaction is with water, दिखता है water, लेकिन ब्रैकेट में देखो G लिखा है, G for gas. Water का gas मतलब steam, okay. It reacts with water vapor or steam and to form aluminium oxide or iron oxide along with the evolution of hydrogen gas. But then there are metals such as lead, copper, silver and gold which do not react even with cold water, hot water or steam. किसी के साथ react नहीं करता है. And therefore they are very unreactive metals, okay. Then of course we have got the next section, what happens when metals react with acids. We know that when metals react with acids they produce hydrogen gas. They produce the salt of the metal plus hydrogen gas, okay. So you have already learned that metals react with acids to give salt and hydrogen gas. So see, the general reaction is there. There is a general reaction, metals plus dilute acid, concentrated acid नहीं, metals plus, it is always better to use dilute acids because they are less accident के chances कम होते हैं. Metals plus dilute acids react to give the corresponding salt of the metal plus hydrogen gas. Zinc plus dilute hydrochloric acid gives zinc chloride, salt of zinc plus hydrogen gas. That reaction is generally used in the laboratory to produce hydrogen gas, okay. Now in this case there is an activity shown out here. Collect all metal samples like sodium, potassium, zinc, calcium and so on. Again, and if they are tarnished, मतलब ऊपर से थोड़ा सा लेयर रफ हो गया है तो उसको क्लीन सैंड पेपर से रब करो ताकि वो क्लियर हो जाए, जैसे कि आयरन और कॉपर. Do not take sodium and potassium as they react vigorously with cold water. इसलिए सोडियम और पोटेशियम को तो छोड़ ही दो because they are extremely reactive. Put the sample separately in test tube containing dilute hydrochloric acid. अगर पानी के साथ सोडियम और पोटेशियम रिएक्ट करता है, सोचो वो कितना रिएक्ट करेगा एसिड के साथ. इसलिए सोडियम और पोटेशियम को टच मत करो. Suspend thermometers in the test tube so that the bulbs, थर्मोमीटर का आगे का पार्ट जहां पे मर्क्यूरी होता है उसको बल्ब बोलते हैं. It is dipped in the acid. Observe the rate of formation of bubbles. हाइड्रोजन गैस के bubbles जल्दी होते हैं या स्लोली होते हैं. Which metals reacts vigorously with dilute hydrochloric acid and which metals did you record the highest temperature? Arrange the metals in decreasing order of reactivity with acids. Okay. So oxygen के साथ, पानी के साथ, अब acid के साथ. Write equations for the reaction of magnesium, aluminium, zinc and iron with dilute hydrochloric acid. Hydrogen gas is not evolved when a metal reacts with nitric acid. Now this is an important question here. You see here. Why is hydrogen gas not evolved with metal reacts with nitric acid? Because nitric acid is an oxidizing agent. It's a strong oxidizing agent. इसलिए जैसे ही हाइड्रोजन प्रोड्यूस होगा वो ऑक्सीडाइज्ड होगा, वाटर के ऑक्सीजन के साथ रिएक्ट करके वाटर बन जाएगा, okay, and therefore hydrogen cannot be evolved. Once again, nitric acid is not used with metals to produce hydrogen gas. Hydrogen gas जैसे ही फॉर्म होता है, because nitric acid is a strong oxidizing agent, ऑक्सीजन के साथ रिएक्ट होगा हाइड्रोजन और पानी बनेगा, हाइड्रोजन इवॉल्व नहीं होगा. Hydrogen gas is not evolved when a metal reacts with nitric acid. It is because nitric acid is a strong oxidizing agent. It oxidizes hydrogen produced to water and itself gets reduced to any of the nitrous oxide or dinitrogen oxide. Okay, but magnesium metal and manganese react with very dilute nitric acid to evolve hydrogen gas. ये exception है. You have to learn that. Magnesium और manganese के साथ very dilute hydrochloric acid, nitric acid के साथ हाइड्रोजन होता है, but mostly nitric acid is never used, okay, in the lab. लैब में हम हाइड्रोक्लोरिक एसिड या तो सल्फ्यूरिक एसिड यूज करते हैं to produce hydrogen gas with metals. Okay, so this is an important question. Why is hydrogen gas not evolved when metals react with nitric acid? There is one more question. What is ectaresia and what are its uses? Okay, just let's proceed further for a couple of minutes. You must have observed in activity 3.11 that the rate of formation of bubbles was the fastest in the case of magnesium. The reaction was also most exothermic in the case of magnesium. The reactivity decreases in this order. Magnesium is more reactive than aluminium, aluminium is more reactive than zinc, and zinc is more reactive than iron. In the case of copper, no bubbles were seen and the temperature also remained almost the same. This shows that copper does not react with dilute hydrochloric acid. Okay, so this is the reactivity of metals with water, oxygen and acids, dilute acids. Now what is aqueous regia? This question is, what is aqueous regia? Alright, the question here was, what is aqueous regia? Just give the question out here. What is aqueous regia and what are its uses? See, aqueous regia is a very powerful compound, and therefore you got to be careful. It's a powerful mixture actually. It's not even a compound. It's a mixture of two acids, concentrated acids. Aqueous regia, Latin for oil water, is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid. दोनों concentrated है, लेकिन वो mixture है. Okay, दोनों को mix करते हैं. कौन से रेशियो में? 3:1. 3 parts हाइड्रोक्लोरिक एसिड, 1, मतलब अगर 4 ml है तो 3 ml 3 मिलीलीटर हाइड्रोक्लोरिक एसिड और 1 मिलीलीटर नाइट्रिक एसिड. इट कैन डिसॉल्व गोल्ड ऑल्सो. सोनी होता है ना, सोनी, गोल्डस्मिथ. गोल्डस्मिथ को बहुत यूजफुल होता है ये एक्वायस रेजिया. जब सोनी को गोल्ड को डिसॉल्व करना है, गोल्ड या सिल्वर को या तो प्लेटिनम, तो ये गोल्डस्मिथ क्या करता है? एक्वायस रेजिया उसके पास होता ही है, वो एक्वायस रेजिया में उसको डिसॉल्व कर देता है गोल्ड को, और फिर उसको देयर इज अ केमिकल प्रोसेस ऑफ रिक्लेमिंग द गोल्ड. इट कैन डिसॉल्व गोल्ड इवन दो नाइदर ऑफ दीस एसिड्स कैन डू सो अलोन. अगर गोल्ड नाइट्रिक एसिड में डालो तो कोई ज्यादा फर्क नहीं पड़ेगा, हाइड्रोक्लोरिक एसिड में डालो तो भी नहीं. लेकिन तीन का मिक्सचर है ना, ये दोनों का मिक्सचर जिसको हम एक्वायस रेजिया बोलता है, दैट कैन डिसॉल्व गोल्ड एंड सिल्वर एंड इवन प्लैटिनम. कैन एक्वायस रेजिया इज अ हाईली कोरोसिव. एक्वायस रेजिया इज अ हाईली कोरोसिव सब्सटेंस. इट्स अ फ्यूमिंग लिक्विड. फ्यूमिंग मतलब उसमें से गैस जैसा निकलता है, फ्यूमिंग लिक्विड. हाईली कोरोसिव, कोई भी मेटल को कोरोड कर देगा. It is one of the few reagents that is able to dissolve gold and platinum. Platinum is one of the hardest metals. उसको भी dissolve कर देगा. So it is used mostly by goldsmiths. Okay, aqueous regia. All right. How do metals react with solutions of other metals? We'll do this tomorrow. We'll carry on with this chapter and slowly. Chemistry, remember, a little effort is required. Okay, effort के साथ थोड़ी memory work भी बहुत ज़्यादा होता है. I've explained that to you before also. All right. Enough for today. Keep working. Keep learning. When you watch the videos, those who have not subscribed, please subscribe it and make it public. Make your subscription public so I know who has subscribed. At the same time, like the videos and definitely make a comment. Even one word of comment after watching the video is more than enough. Okay? Press the thumbs up button for like and write one sentence or even a couple of words after watching every single video. That's good enough. Okay? Thank you. Have a nice day and stay safe.